Hello students, this is Unit 2. Unit 2, lesson number 3, so we're going to start out with 3.1, which is finding a relationship. So let's just look through these here. They're basically on page 147. They're giving you a set of numbers here. You have some x values and some y values. These are ordered pairs of x comma y. So what they're trying to say here is what's some strategies that you could use to find the relationship. So they're really worried about strategies and seeing what we can come up with. Well, this is kind of a unique situation, and sometimes it's not intuitively obvious to the casual observer what's going on here. So I'm going to go and show you some other strategies that we can use to kind of figure out what's going on here. And so if we look at this, these don't immediately jump out how you get from the x values to over here to the y values. So let's go ahead and look at the book itself. So what I did was I took these and I went and just like wrote down these as ordered pairs. So 0, 1, or excuse me, this should be 1, 0, excuse me. 1, 0, 3, 8, 5, 24, 7, 48. So let me fix this real quick here. This is 1, 0, which tells you the x value and how it's been paired with the y value. There we go. Now we are all set. And as we go through this, if I was just to go and start out with, this is one of my favorite ways to go and kind of analyze this stuff. Let's just look and see what it looks like. All right, so if I start putting in ordered pairs, and I just have these like 1 through 9 on the x value, and 0 through 10 on the other, you kind of see start here with we'll start with 1, 0, which is like right down here, and it kind of just like curls up. Ignore this, all right? And it kind of curls up like that, and you see it very quickly jumps up. I mean, you can't really even draw a straight line between the two because it's so quick to go up. And that's not what normally happens. Normally, if you have a kind of a what's called a linear relationship, one goes up, the other one goes up by a certain amount. One goes up, the other might go down a certain amount. Okay, so you could have something that looks like that. And so a linear line is ultimately what you're looking for when you graph this stuff. And normally it's just x comma y, but you don't always have to go and just graph x comma y. So what I've done is I've kind of shown you this another one right here. Let me go and move myself out of the way here. If you look here, I've got the x values, and then on the other side I put the x and I just simply squared them, right? And I just kind of like put 4, 9, 16, 25, 36, 49, 64 as I squared 1 through 8. And again, I chose 8 as the upper bin because 7 was the biggest x value that was given on our our sheet here. So like that. I don't need to go much higher than that. So if you look at this, when I started growing that, now it becomes a linear line. Now it was like, I kind of figure out what's going on here. So this is a big indicator that between the x value and the y value, I took the x value and I just simply squared it, and that's where the y value had come in. All right, and I got a nice straight line, like, aha, I have now figured that out. All right, and this is going to come in very handy if you have this technique. One, take the numbers that are given, make ordered pairs out of them, and just simply graph them and see if an x squared might happen. Later on, you're going to learn about things called logarithms. You might want to think about logarithms. You might want to think about things to the third power, exponential functions, trigonometric functions. There's any number of functions, but we're going to keep it fairly simple here. So on this one, my first instinct out of the box, let's try squaring function. And what happens? Well, it pretty much forms a straight line. Well, that's a big indicator that x squared thing is what I need to worry about. Okay? So if we go back to here, all right? And now, what's happening here? Well, if I took the first one and I squared it and then subtracted 1, I would get to 0. That's how I would make the first one work. Take the x, square it, and then I say, well, that gives me a 1. How do I get back down here to 0? Well, I just simply subtract 1 and I get 0. Well, let's try that same idea here. 3 squared is 9. How do we get from 9 down to 8? Well, just simply subtract 1. Well, that kind of worked again. Let's try this one. Well, we have a 5. Let's square it. That gives me 25. And how do we get from 25 down to 24? Well, I just subtract 1. So it just kind of falls in line. And does it work on the last one? 7 squared is 49. 49 minus 1 is 48. And so, yeah, that kind of works too. So that's what I like about this. Let me go and fix their little 8 there. Looks a little bit better. There we go. So you see, that makes perfect sense, and that's what our ultimate goal was. All right. So again, some techniques. Graph it. Just simply graph it. And if you find one that's still kind of curvy when you don't like it, try a different function. Okay. Let's go down to this next one here. All right. Now this one, what they're doing is they give you a table A, table B, and let me go and just go back over here. We'll go down. So if you see right here, all right, you have 0 and a 0, a 1 and a 400, a 2.5 and a 1,000, a 6 and a 2,400, a 9 and a 3,600. Well, you might kind of recognize what's going on here, because if you go from the x to the y, 0 to 0 doesn't tell you much. But how do I get from 1 to 400? Well, I could either add 399, or I could multiply by 400. Well, how could I get from 2.5 to 1,000? Well, I could add 997.5, or I could multiply by 400. How would I get from 6 to 2,400? Well, I could add 2,394, or I could multiply by 400. Same thing here with 9. I could go do the subtract thing, or the addition thing, or I could do multiply by 400, and I get down here to 3,600. So it looks like I just take the x value, multiply by 400, and I get the y value. All right. So let's go and look at that real quick. And so that's when the number of laps x is multiplied by 400. This gives you the meters run. So the y value right here equals 400 times whatever the x value is. So that's your kind of what's going on with this one. All right, let's look at the next one. Well, let's see. I start with 0 and end at 400. I go up to 75. Well, now I go down to 325. I start at 128, and so you'll notice that these are increasing, but these keep dropping. Okay, so that should tell you a lot about this. That as one increases, the other decreases. Well, let's see. 128. You put in 128, you have a 272 for an output. 319, and this goes down to 81. 396 to 4, and so you might look at these things. It's like, you know, it's weird when you add these two numbers, the x and the y together. I start to get 400. So in the answer key, this is subtracting meters from the home for $400 gives you the same meters as from the school. All right, so let's look at that real quick. What they're trying to do there, what we've noticed is, if I take the x and I add a y, I get 400. That's what we're trying to figure out. Now, if you look at this equation, you say, well, gosh, I'd like to just have the y on one side and the x on the other. So I have to go and get rid of this one on this side and hopefully end up make it show up on this side. Well, you'll notice what happens between the two. You've got an x plus a y. So if you want to get x all by if you want to go and get y all by itself, you have to go and remove that x. Well, how do you undo addition? Well, you undo it with subtraction. So if I just simply subtracted x from both sides, x minus x is boop, nothing. It went away. And what do you have? Well, you end up with y equals 400 minus x. All right. So this is a perfectly acceptable answer for how this is related. This is a perfectly acceptable way to state how they're related. So either one of those really is a good answer, right, for this one. So let me go back to our answer key real quick here. And so this is what we have down here. So we have a couple different ways that you can represent this. Y equals 400 minus x, or x plus y equals 400. So either one, perfectly good. Let's see if we can go on to our next one here. So on letter C, table C, we go from 85 to 485. We go from 124 to 524, 309 to 709, 816 to 1216. So you can notice it's like, wow, it looks like I added 400 to each one of these things. So what they're trying to get you to say there is that if I take the x and I add 400 to it, I get the y value. All right, and so that's a perfectly acceptable answer. You'll notice how this looks very similar to it, but it's a little bit different. Still got an x, still got a y, still got a 400, but this actually describes what's going on. You're going to start with the x, you're going to add 400, and that's going to give you your y value. And then when you go through this, the total expenses is 400 more than the electric bill. All right? And so y equals x plus 400. So pretty straightforward. And letter D. So you got monthly salaries in dollars, amount deposited in dollars. So you go from 872 to 472, 998 to 598, 1015 to 615, 2110 down to 1710. And so you might want to see what's going to be going on here. And so it looks like you take this number and you simply drop it down by 400. And if we got there, you get this y equals x minus 400. And so when we get down to the very top bottom here, it says to match the table of the equation representing the relationship. So it looks like C is the answer for that first one. Table D is the answer for the second one. Equation 3 goes with table B, and then equation 4 goes with letter A. Okay? And so we can go through, and this next one was a lot of fun that some of my students had in Mapleton. What they're asking you to do is express every number between 1 and 20 at least one way using exactly 4 fours and any operation or mathematical symbol. So it says, for example, 1 can be written as 4 divided by 4 plus 4 minus 4. Well, what's 4 divided by 4? Well, that's 1. 1 plus 4 is 5. 5 minus 4, 1. All right? But that's just one way that you can do it. There's a number of ways that you can do each one of these. Let's look here at number 2 here. So on number 2, what we got, this is just as an example. You can do it any way that you want. So 4 divided by 4, that's 1. Plus 4 divided by 4, that's another 1. 1 plus 1 is 2. How can you do number 3? Well, you can say 4 plus 4 plus 4, which is 12, divided by 4 is going to be 12 divided by 4, which is 3. And you'll notice in every one of these cases, I have 4 fours being added, subtracted, multiplied, and divided together. All right? So let's just go through. I'd like you to go through that in class just to see how many different ways you can come up with them. And literally, for 1 through 20, there's probably at least 100 different ways that you could go and do the number sets between 1 and 100. When I was in high school, we did the same thing, only we went from 1 to 100. All right. So there's a few things I want to make sure that you understand. All right. Let's start with some exponents. 4 to the 0 power is 1. Anything to the 0 power is 1. Even 0 to the 0 power is 1. All right. So if I take the 4, I take it to the 0 power, that's 1. 4 to the first power, anything to the first power is the base itself. All right, so that's 4. If you had like 2 to the first power, that would be 2. If you had 115 to the first power, that's 115. Okay? You should be able to figure out this one. What's 4 squared? Well, the answer is 16. All right, and when you get to the closer to 20, this becomes real important. Okay? And so you can all, if you do 4 cubed, that's 4 times 4 times 4. Well, that's 64. So if you decide to do this between 1 and 100 for extra practice, then that one comes in really handy because it quickly ratchets you up into close to 100. All right. You can also do the square root of 4. All right. What's the square root of 4? Well, that's 2. So that becomes real handy as well. That's another one that you can use if you so desire. You can do 4 factorial. All right. A lot of you might not know what 4 factorial is. Okay, so this is an exclamation point, right? This is an exclamation symbol. All right, well that's 4 times 3 times 2 times 1. Okay, we go through the math. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So out of that you get 24, which is another good number that you can actually use because it ratchets you up very quickly. All right. For example, if I had 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1. Well, 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. So that actually turns out to be 720. You just added on a couple of different numbers in there, and voila, you've got that. Just out of a little thing here, what's the difference between this and this? Well, you've got 6 times 5, which is the extra parts here. 6 times 5 is 30. If you take that number times 30, you're going to get 720. All right? So that's the kind of the nice thing about this thing. We'll talk more about this in later math when we do, well, gosh, binomial expansions and combinations and permutations and stuff like that. But we'll come back to this. But for right now, you don't really need to know this one. But this one could be handy when you want to complete that little part there. And I'll let you go and do that in class. And I'll probably go and have you hand that little part in as a homework assignment. So I would suggest you go through that. And yes, you can go and work with a partner on that. That's perfectly fine. But remember, only 4 4s, and that's it. That's all you can use. All right. You can use grouping symbols. You can say like 4 to the 0 plus 4 to the 0. All right. Times 4 to the 0 power times 4 to the 0 power times 4. Well, let's see what that turns out to be. 4 plus 4 to the 0 is 1 plus 1. All right. And you're multiplying times 4 to the 1, which is 1. All right, and then you could always just like add the 4 onto the back end here, plus 4. So what's this turn out? Well, you got to do the stuff inside the grouping symbols first. All right, 1 plus 1 is 2. There's your 2. All right, times 1. All right, plus the 4. 2 times 1 is 2. 2 plus 4, and oh, that turns out to be 6. So here's your 4 4s. 4 to the 0 plus 4 to the 0 times 4 to the 0 plus 4. All right, and we just show the little math that comes down here, and hey, it equals 6. Lovely. But yeah, I'm going to have you go and turn that in as a problem set for you to go and work with. Okay. And let's move on here. I'm going to go and stop this one, and I'm going to go and work through 3.3 on their next video.